right, we are now in section 3.6. So welcome to section 3.6. And what we'll talk about here is what we call the chain rule. So that means by the word chain, there's a chain reaction. Think of it that way. And it has to do with derivatives. But before we go into the derivatives, let's review first what we do with compositions of functions. Okay, so suppose we have f of x is equal to x cubed, g of x equal to 2x plus 1, and h of x, say, is sine of x. Now, when I say f of x, that means the function is acting on the x, and what happens here is that x is being cubed. So if we take the x, that's what we're going to call from now on the argument of the function. So if we say replace the x by u, then we've got f of u becomes u cubed. All right, so if this is z, the argument becomes z, f of z is z cubed. So let's do that. Suppose, right, so when we say the argument, the function is acting on u. So now we change the argument, it becomes f of u becomes u cubed. All right, similarly here, suppose we change the argument, say f of z, then it becomes z cubed. Okay, so now suppose we say f of g. Okay, so this is what we call composition, because the function, instead of just acting on x, the function is acting on the function g of x. So this is what we call f of g, or what we call f circle g. That is the composition, and what's happening is, instead of f of x equal to x cubed, what we're going to do is replace the argument by a function itself. That's why we're composing. So it becomes what? This now is being cubed, but instead of just the x or the u or the z, our argument is a function in itself. So we replace that by 2x plus 1. So that is what it means to compose f with g. Now suppose we continue and say, can we compose more than two functions? Indeed we can. So what is going to happen is that, suppose we want to do f of g of h. Now what does that mean? That means we embed h into the argument of g, okay, and then g is embedded into the argument of f. So how is that going to look like? Well, let's see. You start from something is being cubed on the outside. Okay, now on g, what we have is sine of x is being embedded. Okay, this thing is being embedded into the argument of g. So we don't just say 2x plus 1. Instead, what is being cubed is 2 times the sine x plus 1. Right? So here is your h, which is embedded in g, and then g is embedded in f. So what we've got here is really a composition of three functions. So we start from the outside, going in and keep going in. Similarly, if we start from the inside, whatever's the inside is embedded here on g, and then g is embedded on f. Now these are just examples. Now we can do different kinds of compositions. Suppose we want to look at, say, what is h of g? So that means you are looking at the function h, and you're changing the argument of h to another function g. So in other words, what we got is the sine of x. Instead of the x, we replace it by g. But what is g? It's 2x plus 1. All right? So if we change this again, suppose we have f of h. What is f of h? What does this composition say? That means if you have an f of h, you look at the argument of f. Now, what is the argument of f? It's x. And what are we at? What is the function doing? It's cubing it. So that means I'm going to cube something. So now, instead of the x being the argument of f, okay, f is now acting on h. So what should I plug in here? What do you think should I plug in here? It's going to be sine of x. But by notation, whenever we raise trigonometric functions by a power, we don't leave it this way. We write it as sine cube x. And you can compose different ways. Let's try another one. Suppose we want to compose h of g of f. So in other words, h is acting on g, and then g is acting on the function f. Right? So what is the big picture? The big picture is the sine of the argument. So now we'll take the sine of what though? Okay, so now we'll have to decide what's going to go in here. Well, it says the sine of g. So we replace the argument of h by g. So it's going to be 2, but times what? What is in here? Plus 1. Okay, so this is g that is acting on f. So this becomes, what should I put in here then? Instead of just the x, it'll be what is the argument of g? It's the function f. So this becomes x cubed. So this whole thing is h of g of f. All right. So this is all just practice. Try, just for your own purposes, try different things. Like say, what is f of, we already did f of g. So let's see, what is f of h of g? Try that. Try h of f of g, and just, see what happens and what do you come up with. Okay, you can also try g of h. Have we done g of h? You can try g of h. Now what is this? That means f is acting on the h, and h has its argument acting on g, the function g. So 1, 2, 3. Okay, 1, 2, 1, 2. I'm looking at the parentheses. So here the outer function is h, and it's acting on f, and f is acting on g. All right? Here you just have a composition of 2. So h is embedded in g, so g is going to act on the function h. And then just try, what did you come up with all these 3 compositions? Okay, so that's the most important thing right here, is to understand what is composition. Now, since this is in chapter of derivatives, let's see how do we take the derivative of composition functions. Right, so review of compositions again. Let's look at this. This is a problem in your homework, and I just cut and paste and see. It says there, write the function below in the form y is f of, what is its argument? U. Now u is g of x. And then eventually we're going to find out what is dy by dx. In other words, what is the derivative of y with respect to x, not with respect to u. So that's where chain rule comes in. So here, what we've got is, this is the result of a composition. So the question is, can we extract what was the original f and what was g? Okay, so let's see. If you can see, it's just like from the previous slide, the whole thing was cubed. So what do you think f of u is? In other words, what was the original function that y started with when it was acting on the variable u? I would say it's something cubed. So that means f of u is u cubed. Now what do you think is u? Or what is f acting on? So u is the function g of x, so that means it's in terms of x. So if you look at that, this is a composition of f of g. See that? F acting on g. So that means what we have is f of g is equal to g cubed, and since g is 5x minus 11, see how that is what our y is equal to. In other words, what we've got is the composition, and it's asking us, well, what was the function to begin with, and what is it acting on? It's acting on g. Now you can just try and test. Okay, let's check if this is the correct answer. Okay, so let's check. What is f of g? F of g would be something that f does. It's cubing the argument. So that means you just replace u by 5x minus 11, and indeed this is what y is. It's the composition in itself. So the question now is, how do we take the derivative? All right, so turn to the next slide. So we've got an x, and x is embedded in g. Now g is embedded in f, so that's why you have the composition f of g. See, f circle g, or f of g. Okay, it turns out that the derivative of a composition is the derivative of f with respect to g times the derivative of g with respect to x. Right. So here's our example. Go back to our example. Y is equal to 5x minus 11, quantity cubed. Okay, the whole thing was cubed. So here your u we're acting on. The argument of f is that u is 5x minus 11. See, then that's why we have y is equal to u cubed. All right. So if we look at this, what is dy by dx? According to the derivative of f of g, it's equal to the derivative of f with respect to its argument. So in this case, it's the derivative of y with respect to u. All right, so we'll write that down. It's the derivative of y with respect to its argument, which is u, times the derivative of u, whatever was embedded in your original function, times the derivative of x. And as you can see here, it's almost like you have a cancellation of du right here, and that's where you get dy by dx. Okay, so basically what it is you take the whole picture of y, which is acting on u, and it's cubing it. So what is the derivative with respect to u? That's just 3u squared. But you don't stop there. You take the derivative of the argument of the function y acting on u. So you multiply du by dx, and du by dx is 5. It's just 5 because it's 5. The derivative of 5x minus 11 is just 5 minus 0, so it's just 5. So if we're going to write this down, okay, that's going to be, right, dy with respect to u is 3u squared times u prime. And from there, we could see that I can write it up here so we have more room. It's going to be 3 times, what is u? 5x minus 11 squared. We use the power rule on the whole thing, multiplied by the derivative of the argument. What is u is, it's 5. Okay, so in general, that's what happens when you take the derivative. You take the derivative of the outside function, then you multiply by the derivative of the inside function. Okay, here is just the formal definition from Theorem 2 of your ebook. The chain rule if f of u is differentiable at a point u equal to g of x, and g is differentiable at x, then the composition f of g, okay, what does that mean? You're embedding f into the, where you're embedding g into the argument of f, okay? And it's equal to, what is the derivative of a composition? It says it's a derivative of f with respect to its argument g multiplied by, that's where we use the chain rule. That's what chain rule comes in. Take the derivative of g with respect to x. Now, the previous slide, I used this kind of notation. Now, I want you to get used to different kinds of notation. That way, if you're going to different application of math, whether it's engineering or physics, then you'll get used to these kinds of notations. So when you say y is a function of u, and we want to take the derivative of y with respect to x though, not with respect to u, okay, so dy by dx is equal to dy by what? What's the argument? By u. And then we need to multiply by du over dx. And you see how I said that's kind of what happens is we want to get dy by dx. So this is almost like it's canceling, and what is left is dy by dx. Okay, so what's du by dx? That's the derivative of g with respect to x. What is dy by du? That's the derivative of y with respect to u, and u is g. Okay, so the best thing to do with chain rule is really to practice. Okay, so let's see if we can look at all these different compositions and see how we can take the derivative. Right, let's take this example. Here you have y is equal to 3x plus 2, the whole thing squared. Now, suppose we didn't do chain rule, right? This is how it is. Without chain rule, what is y? So let's look at y first. So y is equal to, if we square this whole binomial, it's going to be 9x squared. Okay, plus what's the middle term? And then the third term is, we know, is 4. The middle term is twice the product, so plus 12x, because that's 3x times 2, double it. Okay, and then you add, right? So do you remember how we take the derivative? Well, that's just y prime here would just be 18x plus what? 12. All right, now with the chain rule, what we're going to do is, all right, so we've got y is, we leave it the way it is, 3x plus 2. According to chain rule, when we take the derivative of y with respect to x, remember it's with respect to x, you take the derivative of the outside going in. So in other words, what is the big picture? The big picture is that something was squared. So if we use the power rule on something that was squared, it will be 2 times the something, right? But then you don't stop there. You multiply by the derivative of what is inside. What was that something? So power rule on the big picture, so it's 2 times 3x plus 2. So this is really taking the derivative of y with respect to its argument right now. Okay, and then we don't stop there. We multiply by the derivative of the inside. So this is like your f acting on g. The g is the 3x plus 2. So that's 3. So if we simplify all that, that becomes 6 times, right? You multiply 2 and 3. 6 times 3, that's 18. And then 6 times 2 is 12. And you see that we arrive at the same derivative. Okay? So that means, well, if I can use it without chain rule, I'm fine. But look, suppose we have something like this. Suppose y is 3x plus 2 to the 7th. Now here's where we can't use it. We cannot do without chain rule, because you would be able to expand 3x plus 2 to the 7th power using the binomial theorem, but that's too tedious. However, if we take the derivative here using chain rule, that's using the power rule on the big picture, and then you multiply by the derivative of the inside, which is 3. And then you just replace that by whatever we acted on. So here, see how simple, taking the derivative of compositions using chain rule. So that becomes 21 times 3x plus 2 raised to the 6th. Okay, so let's see if we can practice some more. Here is a few examples. We have y is equal to 3x plus 5 raised to the 3rd power. So what is the original function? If you let y be equal to f of, say, u, what do you think is f of u? Well, it's u cubed. Now, dy by dx says that we want to take the derivative of y not with respect to with respect to u, but rather with respect to x. So remember that this is your u. Okay? So what is y prime? So the whole thing is you go take the big picture, and then you take the derivative of the big picture, and then you keep going inside into the embeddings rather. So it's 3 times whatever was the argument, 3x plus 5. And then we don't stop there. Then we multiply by the derivative of the inside. What is the derivative of 3x plus 5? It's just 3 plus the derivative of a constant is 0. So that becomes 9 times 3x plus 5 whole thing squared. All right, now here we've got another one. Here is where even if we had to use, this is a very complicated function. It's a cubic function. It's raised to the -2. So what do you think is y prime? Well, let's see. Y prime would be, again, take the big picture. The whole thing is that u is raised to a -2. So what is our u? The one that's embedded here. So what is the derivative with respect to u? It's -2 something u raised to the -3. Because it's negative, use the power rule. -2 minus 1, that's where your -3. And just copy the argument. It's x cubed plus 2x squared minus 4x plus 1. So this is just applying the chain rule, the power rule on the whole thing. But we don't stop there because it's not just x that's sitting here, you see? It's a whole function in itself. So we take the derivative of the inside. So that is equal to 3x squared plus 4x minus 4. There we go. All right. Now let's look at the 4th one. Here, another way of writing this is like here. Let's see. We take, remember when it's a trig function that's raised to the 4th power, this is basically saying we're taking the sine of pi x plus 1 raised to the 4th power. Okay? So when we say y prime, what is the big picture? The big picture is something was raised to the 4th power. And what is that something? It's a sine function. So the embedded function is a sine function. But it is not just a simple sine of x. It's a sine of another argument. So here you have an embedding of another function where sine is applying, or it's acting on its argument of the sine. So let's do that. So let's do it one step at a time. What is the big picture? Something was raised to the 4th. So use the power rule. 4 to that something cubed. Okay? So it's what's sitting here. Sine of pi x plus 1. All right. Now, we don't stop there because what happens? We got to take the derivative of the inside. So we multiply that. And it's going to be, what is the derivative of a sine function? It's cosine of its argument with respect to its argument, pi x plus 1. Okay? Now, are we done yet? Well, since sine is acting on another argument, okay, so the derivative of sine with respect to the argument is cosine. We don't stop because the sine has in itself another function, so it's acting on this one. So then we multiply by the derivative of the inside. So it's, what's the derivative of pi x plus 1? It'll just be pi, well, plus 0. Let me write that down, that way you know. And of course, it's just going to be canceled. So in the end, what we've got is, let's write that out. It's 4 pi times, it's going to be sine cubed of pi x plus 1, okay, multiplied by the cosine of pi x plus 1. So here what we've got is compositions of three functions. In other words, the big picture was something was raised to the fourth. What was that something? It's the sine of another something, because sine is acting on another function. In particular, it's the function pi x plus 1. So what you're going to do is power rule on the outside, take the derivative of the inside, but since the inside has another function that it's acting on another function, take the derivative of what's embedded on the inside. So the derivative of the argument of cosine is pi x plus 1. So what's the derivative of pi x plus 1? It's pi plus 0. And then the rest is just, putting the constants in the front, constant coefficients, and writing it properly. And there you have the chain rule.